Hello, I am Ehsan Jafari, an expert in membrane technology. Before we start learning this lecture, just a quick note. I am available for your private consulting, system design, troubleshooting, and procurement. If you need professional support for your business, just hit me up on WhatsApp. Now let's begin the tutorial. Hello everybody and welcome to this training course, Membrane Technology for Water and Wastewater Treatment by focus on the pressure-driven membrane processes, microfiltration, ultrafiltration, nanofiltration and reverse osmosis, and also with a practical tutorial using ROSA software. At first, let's have a look at the contents of this course briefly. This course consists of 8 sections. Section 1, Membrane Basic Principles and Selection Process. In this section, you will learn how to select a suitable membrane system according to the molecular separation size, membrane materials, modules, operating mode, and etc. In section 2, you will learn about the membrane problems such as fouling, scaling, concentration polarization, and how to minimize them. Section 3, Pre-treatment and Post-treatment. In this section, types of the pre-treatment and post-treatment have presented and how to select an appropriate pre-treatment for your membrane to increase the membrane life. Section 4, Membrane Design and Evaluation. In this section, you will learn how to design a reverse osmosis and nanofiltration membranes and how to evaluate them. Section 5, Water Production using reverse osmosis and nanofiltration membrane cost and capacity. In Section 6, a case study has presented, drinking water treatment using nanofiltration. In Section 7, you learn how to design reverse osmosis using ROSA software. In the end, in Section 8, top membrane manufacturers have introduced to get know about the market and the productions. Section 1, Membrane Basic Principles and Selection Process. In this section, at first, we have an introduction to membrane process. Then, the steps for the selection of a membrane will be discussed. That in the first step, determination of the necessary molecular separation size of the membrane, in which the main features of microfiltration, ultrafiltration, nanofiltration, and reverse osmosis and their applications have presented. In the second step, determination of the membrane materials and structure such as organic and inorganic materials, properties, advantage and disadvantage, and so on will be discussed. In the third step, types of the forms and modules have presented, and in the end, we have decision of the process. Introduction to membrane process. At first, let's have a definition of a membrane. A membrane is a thin layer of semi-permeable material that is used for solute separation as transmembrane pressure is applied across the membrane. As a matter of fact, membranes divided by two parts. Membrane filtration include microfiltration and ultrafiltration, and membrane desalination include nanofiltration and reverse osmosis. Let's look at the main advantage and disadvantage of membrane. Some advantages such as high removal efficiency. Membrane technologies for water purification are exceptionally attractive due to their high efficiency. Physical separation. One of the particular advantages of the membrane separation process is that it relies on a physical separation, usually with no addition of chemicals in the feed stream and without phase change. because adding the chemicals may cause problems such as interactions with constituents or may residual removal is needed. Selectivity. Membranes can have intensely high selectivity for the separation of components. There can be a significant struggle of control over separation selectivity by having a large number of polymers and inorganic media usage as membranes. Flexibility. Membrane can be used in the separation, concentration, and purification of a huge variety of materials across wide range industries. A small footprint. The compact footprint of many membrane systems is a big advantage for a growing number of water treatment installations. Many municipalities are struggling to increase water treatment capacity to keep up with rising populations, but often they cannot expand the size of their existing facilities. Relatively simple to scale up. A final issue that needs to be addressed to widen the use of membrane is a scale-up in terms of both process application and the fabrication of the membrane. As main disadvantages of the membrane, high cost and energy consumption and fouling problems have presented. Cost is one of the major barriers in membrane technology. Higher energy consumption than the traditional granular filtration. Capital cost, installation, maintenance, and membrane replacement or defouling are also expensive. Membrane separations also can be encountered with a significant problem of fouling of the membranes while processing some type of feed streams. This fouling can inhibit the rate of permeation through the membranes and that makes them incompatible for such applications. In this slide, you can see some of the applications of membrane processes. Worldwide, the field of application of membrane technology is becoming more and more broad. While its beginnings lay in the field of water purification, in the desalination of the sea and brackish water in arid zones, it is used for decades also for the separation of valuable materials from small water volumes, such as in biotechnology, in the pharmaceutical and chemical industry, the metalworking, and in food and beverage industry. In addition, membrane technology got accepted as efficient and economic procedure for the treatment of high-strength industrial wastewater. Membrane technology has been tested and applied for the last 10 years for the treatment of comparably low-loaded and big water volumes in drinking water treatment as well as in municipal wastewater treatment. Membrane processes are used in drinking water treatment to improve the retention of particles and to remove microorganisms. Some of the other applications such as oil and gas industry, computer industry, lab equipment industry, glass and metal manufacturing, and medicine applications. Different levels in membrane processes development. There are some levels in membrane from membrane element to membrane stage as you can see in this figure. The smallest level is element and the largest is stage and I'm going to explain each of which in the next slides. Membrane element. Membrane elements are sheets in a space that can carry membrane force. This is a sheet of the membrane element. The permeate channel is located between two feed spacers. Once feed discharges to the element, at first it flows to the feed channels and then after pass through the membrane goes to the permeate channel and then discharge to the permeate tube. There is also a pressure drop between feed and permeate sides that we will discuss about it in section 4 membrane design. In the right picture, you see a spiral membrane element. In this element, feed discharge to the feed channel spacers. Feed channel spacer is an essential part of the Spirel-wound module to separate membrane leaves. There are many different types of feed spacers in the market, but the most commonly used feed spacers are ladder and diamond type. Feed spacers are usually made of plastic polypropylene. The operating mode in this type of the membrane is cross-flow. In this operating mode, a partial of feed passes through the membrane and goes to the permeate channel and then discharged to the permeate tube. The retentate also cross the membrane and discharge to the outlet as concentrate. Membrane module. A membrane module is a complete unit composed of the membranes, a housing, feed inlet, concentrate outlet, and permeate outlet. In this figure, the pipe that is located on the center of this pressure vessel is permeate outlet and the other is the outlet for the concentrate. Membrane modules also may contain different membrane configurations, including hollow fiber, flat sheet, or tubular membranes that we will discuss about them in this section in detail. Module connection. Modules are connected in series or parallel. A series connection is used if the permeate yield from one module is not sufficient. Several modules are connected in series so that according to the figure, the concentrate flow of a module serves as feed for the next module and the permeate of the single modules is brought together. With a parallel connection, the feed is distributed to the individual modules connected in parallel. The number of modules in parallel connection depends on required the capacity of the membrane stage. The modules in parallel connection are also called a block. The membrane elements are enclosed in pressure vessels. A group of pressure vessels operated in parallel is called a stage. In this figure, there is a three-stage membrane process in which the concentrate of the first stage is the feed of second stage and the concentrate of second stage is the feed of third stage that is most concentrated. Driving forces in membrane processes. A schematic representation of the two-phase system separated by a membrane has presented. Between these phases, there are various driving forces such as pressure, temperature, concentration, electric potential that this course has focused on pressure-driven force. In this table, you can see also these driving forces, aggregation state, and membrane type, and as I said, the pressure difference driving force in this course has considered. Feed and permeate sites are liquid and the membranes are reverse osmosis, nanofiltration, ultrafiltration, and microfiltration. Electrical potential difference driving force such as electrodialysis, concentration difference driving force such as reverse electrodialysis, and partial pressure difference such as pervaporation. Before discussion of the pressure-driven membrane, let's have a review on the other types of the membranes such as electrodialysis and pervaporation. Electrodialysis is a membrane in the separation process that is derived electrically and is applied in order to separating, concentrating, purifying selected ions and some organic solvents from an aqueous solution. This process rejects anions and cation selectivity and is based on the property of the ion exchange membrane. In this membrane, only cations or anions are transferred directly, and if the membrane is more permeable to cations than anions or anions than cations, the increasing or decreasing of ionic solution concentration will be observed. Therefore, depletion or concentration of electrolyte solution is possible. As you can see in the electrodialysis membrane, there is an external power source to create an electrical potential as a driving force. Membranes are located between the positive and negative charges. Fit as a salt solution in this figure discharged to the system. Sodium repulses the positive charge and attracts the negative charge, but chloride vice versa. But in the way they are removed by the membrane and product and concentrate discharge from the outlets. Let's have a brief introduction of evaporation process. The separation of liquid mixtures through a dense membrane by partial vaporization is called evaporation. Unlike the other membrane processes that have liquid phase in both sides, in pervaporation the phase change from liquid to vapor through a membrane during its transport. Pervaporation is a technique similar to distillation, but there are some differences. Pervaporation is a non-porous membrane and energy-efficient technology that in this process the transmission of heat to the permeate side is derived by partial vapor pressure, a gradient in the chemical potential of the substances on both sides of the membrane. One application of pervaporation technology is for alcohol dehydration, volatile organic chemical removal from contaminated water or wastewater, and hydrocarbon separation due to its energy efficient and aimed removal without the addition of chemicals or new pollutants in different forms. This technique is also applied in the chemical industry to break isotropic mixtures. The transport mechanism of pervaporation is similar to reverse osmosis and nanofiltration membranes and is based upon the solution diffusion model. If I want to explain the solution diffusion mechanism in pervaporation membrane, at first, in the feed side of the membrane, diffusion takes place on the liquid boundary layer. Second, molecules of component are selective partitioning into the membrane. Then diffusion takes place through the membrane mixture, and in the end desorption into vapor phase or permeate side.